Well, I think we can get the talk started. Okay.
All right.
So, all right, great. So, hi everyone. For the ones that just joined, my name is Florencia. I'm your host from OC. Thank you for taking the time to join us today for our Tech Talk Machine Learning with TensorFlow as part of the AI Engineering Job Fair brought to you by ARC. Well, we connect great developers with companies around the world. So if you'd like to learn more about the companies that are hiring, we are sharing the link in the chat. So feel free to join and go through our website. So today we will be learning, as you know, about the machine learning models with TensorFlow. And to make sure you take full advantage of this talk, you can feel free, like during the talk, to drop all of your questions for our speaker in the Q&A section that you have there on the down your screen, and we're going to be answering them by the end of the talk. Okay, so also don't worry about making notes immediately, since we will be sending the recording your way. Okay. So, well, I want to welcome our special guest today. Here with us is Aileen, Senior Front-End Developer at Endava. Aileen worked in different industries as a Senior Front-End Developer, Scrum Master, and Product Manager. Her expertise extends to being an active Angular community organizer, driving innovation and collaboration. So, without further ado, Aileen, the stage is yours now. I want to thank you so much for being part of this event.
Yeah, thank you so much, and thank you for having me. Thank you all for joining, and I hope this is enlightening for you as it has been for me. And as they already mentioned, Shivai, that you already this is not going down anytime soon. Working with machine learning with TensorflowJS, so I hope that you can get new updates, and everybody else interested into machine learning as a web developer, just knowledge itself as to how implement this can help you. So I'm going to start sharing my screen. Can you guys see it? Excellent. All right. So yeah, my name is Aileen. I'm based in Mexico. I've been working in the software industry for 8 years now. I'm also an ambassador of Women Team Makers from Google. And yeah, so this talk, it's not new. It's things that are being evolved and something that come to me. I remember back in 2019, because I had this issue like, okay, I'm doing front end, but I'm also interested in machine learning, deep learning. It was where the hype of deep learning and neural networks was at its top. So I wanted to get into it, but I didn't have a background in data science. So many people are working on this. Many people are sharing resources, and that's how I learned, and that's what I want to share with you today. So for the agenda, so I'm not sure how's the level of anybody here on the audience, so I'm just going to start with explaining the core things about machine learning, so we can all start on a base. And then moving forward, I'm going to talk about the library itself, TensorflowJS, and then the models that are available with TensorflowJS, demos, and cool stuff that we can build with it. So let's start with the first question, and something that it's been hyping around a lot. It's what's machine learning? And so I think in order to understand machine learning, we first need to talk about this other word that it's saying along too much to. It's artificial intelligence. So it's basically artificial intelligence is the science or the field, or if you want to call it discipline, which provides a theory and lets to build machines that think and act like humans. So it's called artificial because we want to emulate the human thinking, right? How can we make machines intelligence or agents? And so with this field comes machine learning. So machine learning is how we create these agents or these machines, making them intelligent. So it's basically a subset or a subfield of AI, and it gives the ability to learn without explicit programming. This chart occurs from Lawrence. He has a great book called AI for Developers, and he explains how this happens. So if you have worked with development in any kind of language, we have requirements, and we have the rules, the business logic, and we create the solution, right? We tell with code how to do things. But machine learning changed this paradigm into the machine is going to create these rules, and how it's going to create it by providing the inputs, the requirements, the answers, and then by inferring, because it has it's more intelligent, it has more time to provide a solution. It would find those patterns better than maybe us programming each of those cases. And also there's TensorFlow certification course by Daniel Berg, and he describes this as, I think it's the best description into when you're cooking, you have a recipe and you have ingredients, and then you put something in the oven and it comes out, right? Maybe a cake. So if we had a machine learning model for creating food, it would be, here is the recipe and this is how it looks or how it should taste. And then this oven will create that. That is a good analogy of understanding how we create the models or how they work. And also something that you have maybe heard a lot is deep learning. So deep learning is also part of the AI, and it's basically it's also artificial, but it's neural networks. This is trying to emulate how the humans think with neural and layers. So it's called deep because it has a lot of layers, and it creates more complex solution. And most of the things that you might be seeing today, like generative AI, large language models, are built upon deep learning. So this is some of the core things or concepts that we want to get into to understand machine learning and implementing it on the web or anywhere. And so this is not new. We're surrounded every time I think there's no product that cannot get benefit from this. And we have seen it because we have always, every day we have an update of a new application using AI to provide a new solution or to create great experiences for the customers. So, and not only for products, but also on health and climate change. There's a lot of machine learning is giving us this power to create solutions that weren't able to create with traditional programming. So we have skin cancer scanners. During COVID, there was an X-ray that could check the lungs. So there's a lot of great solutions, not only based on the commerce, but also on helping us as society. And then on the commerce, you have Netflix, so it can understand how the user is consuming. So it can provide some suggestions, same with Spotify. And then with translation, these models will help you create a better experience for you. And of course, AI, machine learning, deep learning, they're not new concepts. They come from the 50s, and it's because why right now it's the age or the era of AI. It's basically because we have the tools that can make it thrive. Now we can run a deep learning model for hours. We have the power, we have the servers, GPUs, but we also have the data. There's a lot of data that's available from the products that we use day to day, and we use a lot of products every day. We have mobiles. I think the industry of mobile has grown so much, and also the web itself has grown so much that more and more people are accessing these devices and providing data. So that's why it's thriving so much, because we have the right ingredients to make it work. And so now that I have explained a little about how the machine learning environment work, AI, and all these things, I hope we're all on the same core knowledge of this with this really quick explanations and definitions. But now we're going to go to the cool part, which is explaining TensorflowJS or what is TensorflowJS. And most of you, I believe, or maybe not all of you, but most of the machine learning environment has worked around Python data science. And the thing is that JavaScript is also a very powerful language. JavaScript, every survey that Stackoverflow provides year, I think it's 11th year in a row, that it's the most used programming language. So what this means is that we have more people that can do machine learning with just knowing JavaScript. And this is very powerful. That's why I think Google also thought it was a good investment, but also because JavaScript can run in many places. For example, on the client, within the browser, with just vanilla. It can also run on the server or in IoT devices with Raspberry Pi, but also it can run on desktops and on mobile. So this is providing a channel to use machine learning on many devices with one core language. So that's why I think I wanted to kind of show the importance of why JavaScript, right? We want to reach more people. We want to reach more audiences and solutions that can go further. All right, so we talked about JavaScript, and then TensorFlow. It's a library, an open source library by Google. So I think this gives a lot of weight on this because Google is not new to anything regarding AI. They've been doing a lot of solutions, Google Translate, how we redacted emails way before all of these hype. So they have a core knowledge, they have Kaggle for data models. They have a huge community behind AI or machine learning. So I think that's something that you might want to consider when working with machine learning, choosing a library that's or an ecosystem that can provide all of these solutions. Also, because maybe if you already know TensorFlow with Python, you know that TensorFlow has more ecosystems like MediaPipe, TensorFlow Hub, TensorFlow with Python, but TensorflowJS is the only ecosystem that can digest and run all the forms of the others TS ecosystems. What this means is that a model from another MediaPipe, TensorFlow Lite, and TensorFlow, I can use it with JavaScript. I can transform them. So that's also very powerful. That maybe if you have a really cool model that you want to try on the browser, it's possible. And also because there's a huge community within this. Jason Mays has created this amazing community of people creating stuff, and using a hashtag WebML, you can find a lot of these solutions. Also, because while using a library, you're encapsulating all of this complexity. What this means is that having this API available for you to create these models, predictions, and all these functions that are available is very powerful to get you started. That's what you want, right? If you want to learn something, you want to start creating things, you don't want to get into the hustle of installing stuff, or you just want to make it work. How? So TensorflowJS gives you this ability to leave kind of the complexity of understanding the core of itself, the core of the keras, or the core of all these models, how they work. You can just use them. It's not that later on, if you want to create more robust or more complex models, you might need to get into the weeds of it. But if you just want to get started, this is a great place because, as I mentioned, let's remove this complexity to get started. Also, what's the power of TensorflowJS? I can create, as I mentioned, you can definitely create a model. You can train. Maybe you want to use a model that needs something else for your specific application, so you can retrain it and add anything that might be needed for that model, but also just grab something and just plug and play. So this is very powerful thing. And well, as JavaScript can also run on the server, TensorFlow has the library available also for Node. So you can just install it via CDN or just npm install. So that's a great benefit if you want to create these solutions and have, like a common stack of JavaScript. Another benefit is busy. And what I mean with this is that you can train and classify the data of the client without sending it to any other server. So it's just living in the browser. So if you want to comply on something legal, it is very sensitive information like diagnosis or IDs, these kind of things. You want to be careful about how you handle this information. So if you're just using it for scanning passports or something like that, why don't you just the web? It will be private. You won't be sending this information to any third-party server. The next thing is lower latency. And lower latency can be translated also to speed because you're not having to send all of this information back to the server to predict something or to classify it. And also, you have available stuff where you're running the model. So if you're running it on the browser has the ability to connect to a webcam, to connect to a microphone. So all of this is very powerful because you don't have to travel anywhere. It's available for you. And also the importance, as I mentioned, of maybe using it in other devices, maybe mobile and all those things. So that's something very important to how portable these models are. So we have real-time data that's going to be available and on speed, and no need to install anything, right? And lower cost because it's very different to host maybe a model than a CDN. Maybe your web page is not the same cost. Is not the same cost of you serving a whole model instead of just a web page where you'll be running that model. So if you want to get started and you don't want to go into the weeds of creating all these environments, this is a great start. And another benefit is that they can run offline. And what I mean by offline is that after the initial page load, the model and the logic can run entirely offline. So this is very great option if you want to try the models in a remote location or it has poor connectivity. So as I mentioned, making it accessible. How can I make it accessible in remote places, in places that have poor connectivity? This is a great thing. And everybody can open a web browser and run it. So this is how we're making this more accessible. And so how does these models run in the browser, right? So the models have some kind of backend on the browser. So these backends are the WebGL that executes on the device's graph card. So depending on where the user is running these devices is where it's going to get the GPU. Also the WebAssembly, which is CPU, but it kind of makes some improvement on the performance of it, and it can run on all the older devices. This is recommended for small models and WebGL more complex models. And CPU, it's the one that we have for default on the browser. If none of the others work, the default would be running on a CPU. It's going to be slower, but we have this backup of running it on CPU. And then just recently on the Google I/O, they just mentioned that we have web GPU available for the browser on Chrome, on stable Chrome. What this means is that I can run a diffusion model on the browser now that's available. If I used to run a diffusion model on WebGL, it was 3 times slower. And right now it's going to be less than 10 seconds. So this is also, as I mentioned, moving forward in working more on the browser, on the web. And it's a big effort from the whole team of Google, Chrome, and TensorFlow, trying to make, as I mentioned, this available to anybody. And so with this is not just stories that are happening. How can we know that this actually is happening? So this was also shared in the Google this May. So this is how much people have been using TensorflowJS. This is just TensorflowJS. And what this is saying is that since 2020, it has grown 10 times. And now it's 230K weekly downloads and almost 15 million cumulative downloads. So if you see these graphs, it's going up every year because there's also improvement that make us want to try it more. And then there's some dips there that it's saying that people, it's because of December holidays, so it's good that people's taking vacation, but coming with a lot of energy to continue doing a lot of stuff with TensorflowJS. So this is real data. This is what's happening. It's not something that's not sustained. You know, it's growing because people are building stuff. And so now that I know what are the benefits or why I should or could use TensorFlow on the web, why don't we talk about these models that I've been saying, the models that make the machine learning intelligent. So TensorflowJS has as I mentioned, models, pre-trained already models that you can have available. And as I mentioned, TensorflowJS is the only one that can digest the other ecosystem of TensorFlow Lite, MediaPipe, TensorFlow Hub. So if I just want to implement them, I have them available. That is an existing model. I don't need to modify it. How it was trained works for my solution, so that's great. But if the model is constrained by certain stuff that I need to apply to my application, well, in this case, I might need to retrain these models. And I'm also able to do that with TensorflowJS. But also, if there's no solution for me and I need to create one from scratch, I have that ability by writing models with either Node or JavaScript. So either option that you might need for your solution, it's available through TensorflowJS. And I want to highlight the fact that you might find an existing model that can help you. And also, I know that there's also Hugging Face making an effort on having available transformers models, the one that they have that has different options for you to try. So there are options, and there might be already a model that can work or be used with the solution that you're trying to implement. So not that I'm not telling you to retrain or write one from scratch, but sometimes if you want to try something fast, you might find a solution already available. And so I mentioned training. I just want to give like a very high like understanding of what training is or how it's classified. And then there's like the most common training that we have for machine learning. These are not the only ones. These are just the most common. We have supervised learning and unsupervised learning and how they work. So for regression, this is a very common example that maybe you have already seen, which is how to predict a number, a natural number, or any real number. So if I want to predict the house price of something and I give the correct variables to that model, the model can predict the outcome. And the regression is going to tell me, oh, it's any number, right? This can also work for forecasting within companies. They want to know how they're going to go next year and so on. So this is the model or the training that you would be using for that kind of problems. The other supervised learning solution is classification. So for supervised learning, it's how you train the model, and how it's called supervised is because you give data, you clean the data, you gather the data, you try to make it as big as possible for your use case, but also that can work for anybody. Now that you have the data, you're going to label it. Remember, we mentioned that in order to train a model, we give inputs and labels. So in the classification one, in both of them, you need to give a label so the model can understand the features. And that's why it's called supervised, because you have to label all the data that you collected so the model can understand the answers. And then for classification, it's basically it can only be one or the other class. So let's say you want to check if the skin cancer radar that I mentioned, the scanner. So if I want to say if it's benign or malignant, I need to check if it's 0 or 1. That is basically the difference between the regression and the classification. Regression can be any real number, but classification need to end in one of the options that I provide to the model. And then we have the other part, which is unsupervised learning. And this is called unsupervised because you don't give labels. You just collect a bunch of data, and then the model will find patterns. As I mentioned, how the model trained, you give inputs, but in this case, you don't label it. You just give it away. And the two ways that you can find unsupervised learning are the anomaly, which is basically finding an outlier, right? Something that's not common. And this is how the model can predict stuff for fraud, which is the most used one. But in clustering, is you give the data and it starts to cluster all the data in a graph. It starts to put it in certain places. So how does this work? So if I buy coffee it's very likely that I might need a cup. What have people that have been buying coffee have bought? So that's how they get to the conclusion of clustering. So trying to find the patterns that align all together. And this is very commonly used in suggestions for things that you want to buy or recommendations for things that you listen or hear. Sorry, listen or see. So this is, as I mentioned, the most common machine learning ways of training a model. And so what model types do I have available in TensorFlow? So the ones that are available are anything related to vision, which is image classification or object detection. There's also some regarding human body, which is body segmentation, pose estimation. There's a lot of great use cases that people have been using for working out, just to make sure that you're doing it the right way, or yoga poses, or using an avatar that can move as I move. So there's a really cool solution gallery out there that you can check regarding this model. There's also text. So this is one that's very commonly today regarding the LLMs. It's not that big because that LLMs are deep learning, but I can verify the text toxicity. Maybe if I have a blog and I want to make sure that people are not being or not harassing or saying anything that might be harmful for anybody, we could implement this text toxicity to make sure that we create a harmonious or happy community, right? Or sentence encoding, or BERT questions and answer, and conversation intent detection. All of these models are available also for text. The sound, speech, command recognition, and there's others that are available for you. But as I mentioned, these are already models trained. You don't have to. You may, if you want, retrain them for your specific solutions, but they're as easy as just plug and play with your web application. And so, with all of this, just want to go through. We already talk about what is machine learning. We talk about TensorflowJS. We talk about models and so on. So, okay, all of this magic, how can I use it? So, just gonna go ahead and share with you some solutions that we can test out. So, just let me know if. So, for example, I mentioned we could use TensorflowJS, and JavaScript has a lot of frameworks. This is an application I built with Angular. So what this is using is the Coco SSD, which is an object detection model that, based on an image, would let me know what's inside of the image based on the classification that it has. So if I go here and I upload this photo, I'll take some time. It's taking a little more than I expected. Let me try to run it again. Demos. See if it now works. Okay, so I uploaded this image, and the object detection model, Coco SSD, has certain classes, and these classes are, I think there are about 80 classes. So within this image, it can detect and draw over the canvas about where is detecting it. So it says that there's a person with 97% trust. Remember, predictions are always statistical, and they might make mistakes. It's always a prediction. There's wine glass and more people. So this is a model running on the browser within an Angular application, and using this model that can predict. And we can go to the code in a minute. Let me just make sure I have it here. So I'm importing the Coco model here, and installing TensorFlow. So there's two things that I need to import to work with machine learning with TensorFlow. It's first importing the library, and then importing the model that I want to use. And so I have my canvas. I have a detect object function that would work upon me pushing the image or uploading the image to the application. I'm going to encode this image. I have the image URL here, sorry, and then I'm going to save it here. Let me go to the part of the model. So here, I have a constant where I'm declaring the load of that model, and I'm saving it here. Remember, I imported like this. And then as I read the image, I'm going to tell the model to predict what it's. I need to transform, first of all, convert the image into tensors. That's how the library works. You need to use tensors. So in order, a model can receive text, image, video, and then all of those things need to be transformed into numbers. So I'm going to transform that image into a tensor that can be read. So I'm going to say model detect this image, and it's going to put the predictions here. And then I'm going to put here all the predictions that it found based on that image that I provided. And then I'm just going to put there the name of the class, and then also I'm going to write over the canvas where it's finding stuff. And then the prediction has a score, which is basically between a 1 and I think it's a 1 and a 0, to take a percentage, and I'm just going to make sure to translate that into a percentage number that can be read, and that's what it's showing. So this is what's coming from the model. It's a class person, and that is the score that it has. So this is one of the models that can be used in an Angular application, as I mentioned, but there's other ways that you can definitely use it, and it's easier. There's something called teach machine. And remember, we mentioned regression models that have classes. So I'm just going to do something really quick so you guys can get a sense of how we can stuff with this tool. So I'm going to train this model that is available here, and I'm going to provide some images of dogs.
And
then I'm going to provide,
Sorry, just really quick feedback. I think some people are saying they can't really see well, so maybe zooming in a little bit more would help.
Sure.
Thank you so much.
I think maybe in the code, right? I'm sorry. Yeah, I think I'm going to do that once I go to code. Thank you.
Cool. Thank you.
And then I'm going to these images of cat. So I'm basically saying to this model to train based on these images that I have provided and these classes that I have provided. And so now I'm going to make sure it's saying that I am a cat, but I'm going to provide better a file to make sure. So how do you train? You train with data that's going to make the validations on, but you also need to have data that you're going to use to verify that your model is working. So in this case, I'm going to use an image that it hasn't previously seen before. So I'm going to use this dog. And it's 100% sure that this is a dog. And I can also try with a cat that is not part of the data that I've been trained on. And it says it's a cat. So although for training, you might need more data. For this case, it was just for showcasing. But this is how you can use this. But then I have this model. How can I use it? I can just export it, and I have different available options here. Today we're talking about TensorflowJS, but it's providing you with, even if you want to download this model or just import it and how to use it. It's also available for Python and also for TensorFlow Lite, which is the mobile part where you could test it. So this is very easy if you don't want to get into the weeds of coding. You'll need to later on put it in your code. But if this is another very visual, UI way of doing it. let's go to this part. So remember I mentioned models for text. So let me do that now with this one. Yeah, I'm gonna. Okay. So in here, I'm importing the TensorflowJS library, and then I'm importing the model of toxicity. And here I'm running a threshold, which is basically, I want to say what is the minimum that I want to be met in order to classify something. So in here, I'm saying that the model, this is just JavaScript, plain JavaScript. That's why there's no imports here. This is just a script tag. This is code within a script tag. And then I load the model and I provide the threshold where I want them to, where I want it to use to classify this. And I'm going to put this sentence, which is you're the worst. And then the model will classify this. You can provide more sentences. That's why it's an array. But you can provide, you use the classify method of the model within the sentences and then provide me with the predictions. And in here, I get the predictions. This is some of the labels classes available for that text toxicity model. And then for each of the sentences, I just want to make sure that which ones, I mean, if from all of those classes, which one is met? Because all of these categories have itself probability. So I'm going to check from which of these probabilities I get more than 9. So once I classify the sentence with these classes that are provided, I want the model to return to me the only the ones that are over 0.9. So in this case, the model find out that the insult was found with a probability of 0.90 something, which is the threshold that I provided, and it's saying that yes, in fact, this is toxic, this is insulting, and it found it toxic. But if I change this to something like you are the best, and then I refresh, just wait a little for the model. I should have put loading here. See, saved. By the way, I'm using this server just to provide that file to the web. Okay, for some reason it's not running. Oh, here it is. This was taking some time. Sorry about that. But yeah, so as I mentioned, it would classify from all of the classes that it has, but it didn't return anything because it didn't found that specific sentence was insulting or sexually explicit or threat. It was the threshold that I provided didn't found it. So if I check the results based on this, the probabilities, sorry, it needs to match. So it didn't match. Sorry, I did the wrong thing of saying that check the probability. It just checked if it matched or not. So as is, it didn't match, it didn't provide me with a console log of saying that it was. So this is some of the models that we have available. There's definitely more things that we can use. And JSON Maze provides, for example, this. It's also the Coco SSD, the one that I show you with the Angular application, but this is used on a webcam. So what it's going to do, this is code available from him. I'm just showcasing him. So in this case, it's saying that it finds a person within the webcam. But let me put here. Okay, it's a bottle. So this code can be found, and it's using the same model that I mentioned on the Coco SSD from Angular, but on a webcam. So this gives you a way more possibilities of the solutions that you can find. And as I mentioned, TensorFlow has a lot of amazing models that you can definitely use. So I'm gonna pause here. I'm not sure if there's any questions before I continue. I just finally want to show, let me just share something very quick. So, and everything that I'm sharing with you, I learned them from these people. These people have great resources, have very hands-on solutions. So I highly recommend if you want to get more than this less than an hour talk. This is where I've been learning. This is the place that you will want to go. And thank you all for being here. This is how you can contact me if you have any questions or if I can help you, or any of the code that whether if you need to be if you want to have it.
This was great. Thank you so much, Aileen. This was a great talk. I found it super interesting to see you live showing how those models works. So now we have, as I told you, we have time for questions. So some of you have already put them into the chat, but feel free to keep adding them. So we're gonna be trying to answer all of them. Okay, Aileen? Okay,
Yeah,
great.
definitely.
So perfect. So our first question is from Carlos. Hi, Carlos. He's asking you, what are your thoughts on the adoption of JavaScript's machine learning libraries in the industry? And if there are currently any popular companies using JavaScript machine learning libraries instead of common languages like Python?
Perfect. Yeah. Um, there's a podcast from people from Google called People of AI, and there's actually one of the last podcasts that mentioned that the Google Meet uses a model on the browser and they created this model when in the pandemic people were taking calls every day and they needed to sound professional. So this model is running and it's isolating the sound to put attention to your voice only, and that is working while you're using that application. So that's an example. Also, Airbnb uses the scanning of the documents, so that's another use case. And then Hugging Face, for example, they made a test for when to use Node and Python. So as I mentioned, TensorflowJS also work on the server with Node, and actually Node is faster. So, but it depends of what you want to. And TensorFlow made the transformers model that they use for state-of-the-art things they use. It's available also for JavaScript. So more and more adoptions is happening because it works. I mean, devices are out there, and with this, as I mentioned, using this update from Google that you can use now diffusion models. I mean, they're making the platform available for you to continue developing. That's what I think, and some of the examples.
Okay, that's great. And Carlos also have another question that I think it's also good if we have other beginners here. How can a total beginner in machine learning get started in this field? He has been working as a full stack developer for 2 years and he's looking to break into the AI machine learning. What would you recommend?
Well, as I mentioned, all of these resources are great to get started with TensorflowJS. But also, if you want to also learn the Python part, there's Lawrence, who also works on Google, has this book AI for Developers, which is also a course in Coursera that you can definitely take, and it gives you hands-on experience on using sequences, on using convolutional networks, on natural language processing and with Python. So this is a great place. And also, if you finish that course, you could get a certification from TensorFlow. Basically, those are the topics that are being covered. So if you want to get started, those are great places. Also, Kaggle has amazing resources for learning and data and models, also open source that you can try.
That's great. Thank you, Aileen. So we have another question from Jesse. He's asking if there is a place where there are examples of the using of the models you presented.
These are basically in TensorflowJS webpage. I can look for it and just share it. Let me just look for it because I don't have the link right now. But if you go to the TensorflowJS webpage, you'll have the models and also the demos that are available and with the GitHub and everything that links to you using it as I use them today.
Okay, great. And Nitin also was asking if you were able to send some of the code that you just presented also, that will be super helpful for him.
Yeah, definitely.
Great, thank you, Aileen. And we have another question from Paulo, if it's right with you. He's asking, like, he put, using TensorFlow only on the front end seems cool for demos, but it requires the model to be full downloaded on the client side. Would you agree that the production-ready applications would mostly run entirely in the backend using Node.js, for example, and capture inputs and return response from APIs, for example?
Yeah, I mean, as I mentioned, there's some cases that as if you want to get started, this is a great place because you can test it really quick. You don't need infrastructure. But as you mentioned, there might be some places that's gonna be difficult, but it will depend of your application. If I'm just checking for two classes, as I mentioned, a dog and a cat, it would be, like very robust to add it to the server if you can just use it. And as I mentioned, they're being used in some cases in production applications. So yes, definitely there's demos, but there's also production applications running with models on the browser. So it would always depends as everybody mentioned, it will always depends of your use case.
That's great. I wanted to let you know that in the chat, the comments are great. They're thanking you for a great
Thank
presentation
you.
and about an awesome information. So for you to also know that. So
Thank
I
you.
have two more questions, and then we're gonna try to close also the talk. Emmanuel is asking, I'm interested in generating fake bug scenarios for developers to learn debugging. I don't know. Any recommendations?
Interesting generating fake
Debugging.
bug scenarios.
Debugging.
Debuggings. Yeah.
Mm, fake bug scenarios. I was once trying to investigate this part. Kaggle has, I think, because the thing is that you need to have the data, right? I mean, if you want to try something, you need that data, and that's, I think, the most complicated part. And I think Kaggle or Hugging Face have open source data sets, but Kaggle has one for test. I'm not sure if it would cover all of the scenarios that you have, but I think um, that's a place you might want to go. I'm not sure if I answered your question, but if for data, that would be that. Yeah, that's what I think.
Great. We have one more question. It seems that the presentation was great. So, what mechanisms, resource do you use to keep track of all these different models that are released on daily basis by a lot of companies? Also, how do you know when not to use a TensorFlow model so that the browser app still lighter?
So, Hugging Face actually has a newsletter, but it's for papers. So every new model is there. It has like a leaderboard for some, for example, for I believe large language models. So there's Gradio. It's another option that people are just showcasing demos because it's also very easy to use. But I would say I use Hugging Face. I try to check people on Twitter that are very related to that. But yeah, papers have worked for me, and just taking a look at the DevRel people that are really posting a lot of demos. And also the conferences. I'm not sure if anybody watched Google Next has been showing some amazing things that's coming. So go for the AWS conferences. Go for them. Those keynotes are basically where you can find what's going on. But for open source, yeah, I'll say Hugging Face or Kaggle.
Okay, that's great. So Shibai also have a question like, what are your thoughts about training of machine learning models with TensorFlow on the browser? Is it recommended, or do you think it's better suited just for interfacing?
Yeah, I mean, it's gonna take processing time. If it's gonna affect the user, it would depend what you are going to. For example, if you want to grab certain interactions from the user that needs to be live, maybe you want to make sure that there's not too many interactions, because if that's the case, maybe definitely not the place for a model to live in the browser, right? Because you could do batching and then you just send it to the server and it's quicker. The thing is not to affect the user, right? But what if you're in a place where there's poor connectivity, or it will depend on your use case. So I think my answer would be recommended based on the user needs. What's not gonna affect the user?
All right, those were great questions and answers. And because of the time, we still have, we can take two more questions and then we will wrap up. But if you want to keep adding them, I have a question from, let's see, Sudeb, right? Yeah. In the example of image processing with the wine, what would be the process to use if I wanted to determine how many wines are being held by a person and how many are in the table? Is this just another image classification model?
Yeah, the thing with image is that image doesn't count for, it just tells you if something is there. So, but object detection gives you number of people and things and where. So that's why there are two different models, image classification, object detection. For this, you will need object detection. But if you saw the model didn't selected all of the people or all of the wines, so this might need retraining, or maybe the image wasn't that good quality. I'm not sure. We will need to continue testing to see why, because there were more people definitely, and there were more wine cups there, but it just didn't detect it. So it might be something that needs retraining, or maybe the image wasn't great. But yeah, I think the model that you would want to use, it would still be object detection.
Great. So we will have time for one more question. So I'm planning to work on speech recognition model that identifies the location said in the voice and uses Google Map to detect the exact location of the person. It can be a good program to handle logistic issues among the drivers in our company. What approach can you propose for me? I request advice to know the precise model to build.
Yeah,
On the
well, for speech recognition, there's models, but then it says and identify the location set in the voice and use. So it's a speech recognition and said voice and use Google Map to detect the exact. So you will need maybe the sequence, I think was the name of that model. So you can kind of grab that um, memory in case of the place, and then you would do the other. I'm not sure with an API or something. I'm not sure if there's like a model for Google Maps, but I would say with speech recognition, it's like the first place to start. And if you need to get a context or more information, or gather that word stored somewhere as a memory, it would be sequence. I forgot the name of the model, but those two are available in TensorflowJS. But if you don't find a solution there, I'm sure Hugging Face would have something that might work for your
Yeah.
solution. To be honest, I haven't
In fact,
implemented, so
there is this one really cool demo that was created by one of the folks using transformers.js that
yeah.
is able to do speech to text directly in the browser using the transformers.js. So I mean, one recommendation would also be to use that, and once you convert it into text, you can identify what all places are being used. Then you can use the Google Maps API from Google Cloud
Yeah.
to identify the
Yeah.
places.
Yeah, definitely. What Shivai says, you're right. There's a speech recognition to test in Hugging Face. Thank you, Shivai.
Okay, Aileen. Well, due to time, we are going to wrap up the TED Talk here. If you didn't get to your question, feel free to reach out to Aileen after the talk. We're going to be leading her social media. And now to end this on a great note, I'll ask you a question that we ask all of our special guests here. What are the moments when you are programming and make you think like, whoa, I love my job so much? Like, what are those moments?
I think I have had a lot of this feeling when working with machine learning, because there's a lot of things that I don't know and that I'm learning every day. So I think every time I work with a new model, every time because reading and learning just by just watching, it's cool. But once you're actually doing it, you're getting a sense of all the blockers and all the trouble that's not out there and making it work I think those are the moments that make me say, okay, it was worth it. It's working and it's amazing.
Okay, great. Well, thank you, Aileen, so much for joining us
you.
today. I hope you have a great time here. We
I do.
truly have it. So thank you so much, and thank you for all the ones that joined this TED Talk as well.
Thank you. Bye-bye.
Bye-bye. So just in case, this is the end of our chat, but go follow Aileen on her social media. And if you enjoyed this session and want to learn more about the companies that are hiring, we have pinned the link in the chat of our platform. So thank you again for being here. Have a really nice end of the day. Bye-bye.